Hello students, welcome to lecture of Kinematics and Theory of Machine. Myself Patel, and we are going to continue our chapter Acceleration in Mechanism. Okay, we will solve the second example from this chapter, and it is little bit different than our last example, because in last example we have studied the acceleration for 4-bar mechanism, but right now we will study one single slider mechanism. Okay, let's start. So you can see on a screen the given data in a mechanism as shown in figure. So first point is that there is a figure is given in this example, so just we have to consider the scale and we have to draw the same figure in a space diagram. Okay, slider C is moving right with a velocity 1 meter per second and an acceleration is of 2.5 meter per second square. The dimension of various links are AB is equal to 3 meter, inclined at a 45 with a vertical, and BC is equal to 1.5 meter, inclined at a 45 with a horizontal. Okay, determine the magnitude of vertical and horizontal component of acceleration of point B and the angular acceleration of link AB and BC. Okay, let's start. So first of all, let's take the given data here. So you can see here all the length and the arrangement is given, but velocity and acceleration of slider is also given. So velocity of slider and acceleration of slider is given, and with the help of that we will find the velocity and acceleration of both link AB and BC. Okay, so velocity of this is given. So first of all we draw the space diagram or configuration diagram using the dimension. You can see 3 meter and 1.5 meter. So 1 meter is equal to 20 mm. So we will draw first this space diagram as shown in figure. The angles are given here. Now we will draw the velocity diagram. For velocity diagram, which velocity is given? Velocity of, you can see the piston is given. So 1 meter per second. So we have to take the scale 50 mm our scale, okay, for velocity diagram. Now how we can draw this? So in this case we have to draw the, as you know the rule, first is always make the origin point. Okay, origin point. How many fixed point on? You can see this A is a fixed here, so I will write here A, and this D is denoted here. Okay, I can say A and D. Now velocity given is a slider's velocity. So slider always pass through origin and line of action is like this. So we will make here this velocity like in this direction, and length will be 5 centimeter or 50 mm. Okay, and this point we can say this is the C point. Okay, so velocity of C or slider with respect to A. Now consider the velocity of B. This velocity of B we can find with respect to C, and also we can find with respect to A. So let's take with respect to A. Velocity of B with respect to A. Okay, so it will be, you know, the direction will be perpendicular to link. So we don't know the magnitude, so we can draw the figure here. So we will draw this perpendicular to link which will be passed through in like this. Okay, we don't know the magnitude right now. Now second will be like this, as you know that velocity of B with respect to C, you know the direction perpendicular to link. So we will draw this perpendicular from C here in this velocity diagram. We don't know the magnitude, but we know the direction perpendicular to link. We don't know the magnitude. So this intersecting point here, this intersecting point will give the B, and you can check here this AB length is a velocity of B with respect to A, and this vector here, this is the BC vector, is a velocity of B with respect to C. Let's erase the extra. Okay, this is the velocity diagram, and if you draw here like this is the velocity of C with respect to A. If you draw here like this will be velocity of B with respect to C. Like this is the velocity of A with respect to B. And if you make in this direction, this will be velocity of B with respect to A. Let's check the velocity diagram here. Okay, so AD fixed point, then C, B. Okay, this is the velocity. If you measure this distance, you will get the velocity of B with respect to A, and if you measure this, you will find the velocity of B with respect to C. So we will measure, by measurement you will find the velocity of remaining element. Now we have finded the velocity of all element, so we can find the acceleration. Okay, let's start. So for acceleration, as you know that we have to make the table. As you know that for acceleration we have to make the table. So this given data is already we know that, and this velocity we have find it from the velocity diagram. Now let's start the acceleration. For that we will make the table first. And as you know that, first of all, name of the link and length of the link. So AB, BC and slider C. Length of the link is given in a meter, 3 meter of AB link and 1.5 meter for the BC link. Okay. Now, as we have finded the velocity also, we will put in a column number 3 the velocity of all element, in which slider is velocity of slider is already given, and we have finded the velocity of remaining 2 links. Now, for acceleration we will add, you know that radial component and tangential component. Okay, so in this you know that V square by length of the link is a radial component. So we will find the all 3 radial component here. But slider, which is a sliding in a straight line, so you know that radial component is 0 here. There will be no value in a radial component of slider. You can see here this BC link, we don't know the magnitude, but we know the direction which will be the perpendicular to the link. And as you know that acceleration of this piston is already given in an example, in a given data. Okay, so let's start the acceleration diagram. So for that, first of all, we take the scale here. Scale is a 1 meter per second square is equal to 40 mm. Now let's draw the diagram. So for that, first of all, you know that first of all we have to take all the fixed point at a here A dash. Now as you know that acceleration of this slider is given, okay, which is the tangential component and which will be in a line of action. So its value is a 2.5. okay, but our scale is equal to 1 meter per second square is equal to 40 mm. So 2.5 meter is given, so I have to draw 100 mm here. So I will draw like here 100 mm, and this end point will give me the C point, slider point, which is the C dash. Okay, now with respect to C, this radial component of B, I already know that it is given here. Radial component of this, you can see this is the radial component of B with respect to C, and this value is a 0.346. So I will draw this 346, apply the scale, and you will find the 13 centimeter. But in which direction? In direction of this link. So I will draw here like in direction of link 13 centimeter. Okay, like this. And now I will draw here parallel to link in this direction like this. Now I will draw the perpendicular to the link, tangential component. I know the direction perpendicular to link, magnitude is unknown, so I will draw like here, this is perpendicular to link. Okay, consider this point is like here. I don't know the magnitude right now. Now this B with respect to A, you know the radial component. As you can see, the radial component is a 0.173. So if you apply the scale, value will be here, you can see 6.92. So I have to draw in this direction parallel to link. So I will draw this line from here. You can check this like this. Now you can see here we don't know the magnitude, but we know the direction. So I will draw here like this, perpendicular to link, like this. And intersecting point will give me the B dash. This intersecting point will give me B dash. Okay, and this point, if you connect this B point with this A and C, this will give the final acceleration. And you can see here, this will be the radial component and this will be the final tangential component. And here, like this is the tangential component. You can erase extra line. Okay. So this is the acceleration diagram for this mechanism. You can check here, this will be the tangential component and this will be the radial component. Same will be here, tangential component, length line we have drawn the without any length, and then when we get this B point, we will find this tangential, and this will be the radial component. Okay. So first we have to find the angular acceleration of AB. So for that we will measure the distance, okay, of tangential component and we will find the angular acceleration. So you know that alpha is equal to tangential component divided by length of that link, and you will find the angular acceleration. Same will be for the angular acceleration of BC, alpha BC. We need to find the alpha BC, and for that we will find the tangential component and divided by length of that link. Okay. So one other, we have to find here magnitude of vertical and horizontal component of acceleration of B. So you can see here the which is the acceleration of B. So you can see this is the acceleration of B and the horizontal and vertical component. So we will draw the vertical component like this. You can see here, this is the vertical component. If you draw line from the A to this B, this center point, you will find the horizontal. So this distance you have to measure and convert them into acceleration, and you will say that there is a horizontal and vertical component of acceleration B. Okay, thank you.